Hi everyone, today we're taking a look at group anagrams, which is a medium LeetCode question that goes over hash maps in a little bit of a deeper dive. All right, so given an array of strings, STRS, we want to group the anagrams together. Anagrams being a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once, meaning they are both the same length and have all the characters used at least once. EAT and TEA both use one E, one A, and one T. So these two are going to be anagrams along with ATE, which uses again one A, one E, one A, and one T. So we want to find all these anagrams and group them together like so. How are we going to do this? Let's take a look at the solution using a hash map. So like I was explaining before, we want to use a hash map to count all the individual characters. So for every single string, we want to keep track of the individual characters. So we want to note that for this first word, then there's one E, one A, and one T. And we want to, continue to keep track of this for every single word. It'll be in a different order, but essentially we'll have the same thing, one E, one A, and one T. And this would actually probably look something more like starting with T and then going on to E and A, one T, one E, and one A. But we know that for every key here, that corresponding key in this new other element is going to have the exact same count. So at the end of the day, even if they're out of order, the key value pairs are going to be the same. But this is actually something that we want to combat. We want to have them in the same order. We don't really want to iterate through each key and map, and we don't want to do that for every single string. What we would rather have is, instead of having one E, one A, and one T, instead we would rather have some way to kind of universalize this and create it in a uniform string that would store all these different values. And the way we're going to do that is for every single string inside this array of strings, we're going to convert it so to kind of this almost binary looking code where every index we're going to keep track of how many characters. So we're going to start with 0, 0, 0, 0 all the way up to 0, and these indices are going to represent A, B, C, D all the way up to Z. And these zeros are going to represent their count. And then we'll iterate through EAT, for example, and at EAT, we have one E. So we're adding one here. So we're converting this 0 from E. We're adding one to that, so we'll have one there. And then we'll see A. So at the A index, we'll add from 0 to 1. And by the end of this, then we will have a very long string that just looks like 1, 0, 0, 0, 1, blah, 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 blah. There's another one at index T, and then 0. So this is what it's going to look like, and this is 26 characters long. Then you can imagine that for T, we'd have the exact same thing. We'd have this exact same string that just only keeps track of their counts, and it does so in a way that we don't have to go through each of these key value pairs separately. So this is a bit of a difficult trick that makes it a medium question, but this decreases the time and space complexity by quite a bit. And let's actually take a look at how it affects how the time and space complexity are affected. So the time complexity, how many times are we going to go through this? So we have this array of strings. We'll just say we have EAT, TEA, and ANT. So we have this array, and for each individual string, we'll say this is an array of length n. And then we'll say that the max length of one of these strings inside this string is 1, 2, 3. This is n. We'll call that n. Then we know that for each string of length m, in this array of length m, we're doing this m times. We're going to iterate through each of these characters inside it. So it'll be n, where n represents the max value of so this is going to be the longest string inside this array of strings. So time complexity is going to be O of m times n. Now, what is the space complexity going to look like? So space complexity, not only are we creating this new array that we're going to be outputting that contains all the elements inside m, just kind of assorted a little bit differently. So we'd have like eat, t, and ant is what we're going to be outputting at the end of it. So this is also going to be an array of probably size around m. But more importantly, for each of these individual strings, remember, we're creating a hash map. We're creating an individual hash map for each of these strings, which could be of max size n, and we're doing that m times. So the space complexity is going to be also O of m times n, where n again is the max length of a string and m is the total count. So space complexity and time complexity are both going to be the same, O of m times n, and this is about near as optimized as you can get. Let's take a look at how the actual code is going to look, because it's a bit tricky. So now let's take a look at the code. The first thing we're going to want to set is a constant for solution groups, and this is going to be an object, and it's going to be a hash map of our own. But while you might think that it's the hash map that we're creating of each object, it's actually going to take in keys of those strings that we talked about that take in the counts, while the values are going to be the specific the array of all the numbers that work. So this is going to be the object, and then next it'll have a little bit different of a string, and then that'll have a and t, t, a, n, whatever. So the values are going to consist of our actual solution, which is going to be solution equals an array, and inside that solution are going to be all the individual arrays that were the values of our solution group key value pairs. So we have these two separate data structures, and it's important that you know what's being stored in each of them, or what we want to be stored in each of them. Now we can actually go through each word or each string, and we can create those these number strings, these count strings. So for constant word of words, we're going to let constant hash equal, and then we'll use a helper function called hash word, and we'll take, oops, sorry, it's a string of strings. And we'll use a helper function that we'll define right here, function hash word, that'll take in a string, and it'll convert a string to this character, this number array that has all their characters. So what we want to do is we want to create a hash map that is originally just going to be set to all zeros. So it'll be array.array26.fill 0. What this is going to do is create an array of length 26 that is just a bunch of zeros. Now for each of these indices, it's going to be like 0, 0, 0, 0, 0. Now for each of these indices, we want to increment it if we have that character. So we're going to increment through the actual string. I is less than string.length and I plus plus. And now each string at index I should be the individual characters at each string. But we can't exactly say that, we can't exactly say hash of A is going to be incremented, because hash of A is nothing. What we do have are hash of element indices. So what we want to do is we want to have something that converts A into index 0. So we need A to be 0. And it's kind of tricky to do that. There's functions that let you do that in other languages, but in JavaScript, we're going to have to create a global variable or a global object variable that is going to take in key value pairs. So it would be, we can call that here, or we can create that here. We'll call this codes equals, and we're going to create an object where A is the key and 0 is the value. So we're going to do the same thing with every single character. And I'll pause this and I'll restart when it's finished. Okay, so now we have this 0 indexed list of codes, or this object of codes containing the characters as keys, and their values are going to be the actual indices. So now we actually can take hash of A, or we can create hash of A and turn that into hash of index 0, because what we're going to do is now we'll let hash of count, or hash our codes object, and then we're going to take string I right here. So now what this has is this codes string I is the same as codes of and if our first character is E, then codes of E. Codes of E is 4. So this is hash at index 4, and that's exactly what we want. Then we want to increment that. We want to say turn that from 0 to 1, and now we should have an array that looks like this. Like this. So this is what we want. And after the end of this, we can just return hash, and our helper function is finished. And now when we call this here, then our constant hash is now set to the completed, whatever that looks like, this array we have right here. 1 0 0 0 1, etc., etc. That's what our hash is going to look like. And now that we have this, we want to figure out if our solution groups doesn't have this hash. If it doesn't have it, in other words, this is the very first time that we're seeing this key, then we are going to add it. We'll say solution groups at hash is equal to this string that we're on. So we're going to set it, or we're going to put that in an array actually, because that's what we want. String. So now we're setting the key as the array that we have, and the value is going to be it would just be like the 1. So if we haven't seen it before, then we'll set its value to be this 1 array. Otherwise, if we have seen it before, then we're going to push it. Solution groups hash dot push string, so we can push this string, and in that case, that's how we would have these arrays of multiple strings. So that's how that would work. And then at the end of this, then we can work on our actual return statement. So for constant key in solution groups, we're iterating through every key, and this in this case, each time we iterate through, our key is going to be, like these separate arrays, whatever they may look like. Then we will have our actual solution, which I think we set equal to sol. Yep, sol.push, and we're going to push solution groups key. So the value at each individual key, which remember are these arrays of words, of strings, these values are what we're going to append to our solution. So if we push that, then we can just return sol at the very end of it, submit this, then it should work. And oops, sorry, there was a typo. Yeah, I didn't actually set this for loop to start. So we submit this, then this should work. And yep, that's pretty good.